All right, gang, welcome. I appreciate you watching, and I appreciate however it is you find your way to this video, whether you're a subscriber or you just randomly happened across this, or you went to some link that I'd posted in some astrophotography or astronomy or science related group. Welcome. What I wanted to show you, and I've posted some similar videos to this on my channel, but I wanted to just show again how I captured, and this one was actually by accident, an asteroid, a pretty dadgum dim asteroid. This thing is about magnitude, absolute magnitude 10. So as you might imagine, it's about 1/20,000th as bright as Sirius. So if you don't recognize this group of stars here, this is M45, the Pleiades, and I was shooting the Pleiades a couple months back. And unfortunately, I forgot to tell the camera to shoot in RAW. So I shot in JPEG only, which is why the quality is terrible here. But at least I captured this asteroid, so it's pretty interesting. I use PixInsight, and that's part of what you're seeing here. You don't see the menu in the video, but PixInsight has a multitude of different processes built into the program, and one of them is image registration, which is where you align all your images to some baseline image. Then you integrate them, or some software calls it stacking. Oftentimes, after I align my images, I typically do a star alignment, unless I'm shooting a comet, and then it's comet alignment. I'll throw them into this blink process. And all it is, it's a process that allows you to very, very quickly, I'm rolling the wheel on the mouse to go through these images. What it does, it allows you to very, very quickly toggle between 2, 3, 4, or 100 different images, and it'll just cycle through them very quickly. You can see I've got 0.05 seconds. So if I hit play, this is what you get. Now you'll see the field of view shifting and moving a little bit. That's just simple tracking errors during the imaging session. Also field rotation. This is with a Dobsonian mount. So in other words, Alt-Az. So over time, you're going to have field rotation. But oftentimes, I will take my registered images and I'll zoom in and I'll just check the quality of the alignment. And you can see how it's not bad. I don't have any stars that are jumping out here. Some are slightly elongated, so maybe I would go in. By the way, you can see your noise there. This is from the actual pixels on the sensor again. And it's really an artifact created through compressing raw images into JPEG, which is what you get here. So that's why these are terrible. It's interesting to note how your diffraction spikes rotate over time. Again, that is due to field rotation. And it's not so much that the diffraction spikes rotate during imaging. The image alignment process had to rotate each of these subs to get the stars to align so I can have an aligned image. And the result is the second order effect, one of many, is that you can see the diffraction spikes rotating here. But oftentimes, like I said, I'll zoom in real close here and I'll just check the quality of the alignment, see if I got some really elongated stars. And I zoomed into this area right here and I saw this. You can clearly see that it's creeping up to the upper left corner, especially, and I'm going to hit pause. I'm going to go back to the first image. I can actually toggle between first and last. You can see clearly how it moves and none of the others move. So I knew I had captured something. The question is, what is it? I also know that almost immediately, and you'll learn this if you don't know this already, you could see something like this and say, oh, I must have captured a satellite. But if you do the math, and you don't even have to do the math, just know in general that for satellites to remain in orbit around the Earth, especially low Earth and medium Earth orbits, LEO and MEO orbits, they're traveling fast. And if I were to look at the timestamps between the first and last frame here, you'd see a lot of time elapse. By the way, here's our suspicious object. So we know it's not a satellite. We also know it's not a satellite because a satellite would leave trails during the exposure. So maybe it's a rocket body. Maybe it's something along those lines. who knows what. But that's what started the mystery here in Messier 45. My next step in just saying to myself, hey, did I image something that is not normally there? And again, just having imaged asteroids before, I already knew what this was, but I still run through the whole process. I don't take anything for granted. And if I ever post anything that says, hey, here's an asteroid that I imaged, I want to know in my heart of hearts that I've done the research to make sure that it is what I said it is. And not only that, I don't want to just generically throw out and say, oh, it's an asteroid. I want to be specific. What's its name? What's its orbit? When was it discovered? Who discovered it? And also some information about it, for example, its magnitude, because I like to know that, hey, I've imaged something with my telescope extremely dim. So my next step, and I have shown this to you all before, this astrometry.net, where you can click upload and upload a file, and it'll take JPEG, GIF, PNG, or FITS. Almost always do JPEGs. You hit upload, and your result is something like this. And I've already processed it before I started recording this video, and it says go to results page. So let's do that. And by the way, it'll show you, it plate solves is basically what it's doing. It will show you all the major things that are in the field of view of the image you uploaded. So HD, for example, star HD 23246. So and a little side note, let's suppose I upload this to astrometry.net. It gives me this information, and now I want to know where in Stellarium is my telescope looking. And I could actually go to the search function in Stellarium, punch in HD 23246, hit enter, and actually I don't even think you have to enter, just click it, and now Stellarium will slew to this star, and now I know where my field of view is looking. So I always go down to this right here, and I click on the View in Worldwide Telescope. So let's go there. And that pops these windows, etc. And then here is my image. I'm going to zoom out a little bit so you can see this. Here is my image. And you can see how small my field of view is related to M45. Here is my image overlaid on the digitized sky survey, the color version. And I can use this slider down here to turn on or off my image. And I've done this before to image and verify that I've imaged high proper motion stars. In other words, fast moving stars, and they are out there. So if we zoom in, let's first of all go all the way to my image. In other words, slide the slider. Now this is my image only, and then I slide the slider and look at some of these key stars. Where obviously you got my rope, or whatever the name of this one is. It's one of Atlas's daughters. You can look at the bright stars here as I slide my image on and off, and you can see they stay there. You've got this little grouping right here. Sure enough, they're in my image and they're in the DSS image. But look in my image right there. That's the suspect object. If I turn off my image, you can clearly see that there's nothing there. Nothing there. Now, there are some really dim stars here in the DSS image. But if I turn my image on, you can see that I didn't even capture them. Not with this exposure, short exposure time, or in JPEG, remember. So the point is, whatever that object is, it's brighter than whatever this star is. And what that does, that tells me that if this were an object that should be here permanently, certainly it would have popped up, right? So let me repeat. If I've captured it in my image, then I know it hits some certain threshold in terms of brightness. But I didn't capture their little dim thing here. So in other words, there's no way that it's there and we just don't see it because it wasn't bright enough. I hope that makes sense. There's other examples here too. I don't know. That's probably a galaxy, by the way. You could pick a dim star here and then ask yourself, well, it shows up in their image, but not in mine. So that told me that, again, it is an object that is not normally there. So the next step then is I just went to Stellarium and I looked in that part of the sky in M45 during the time frame of these subs. I don't have Stellarium called up here. I won't bore you with that. To look and see, and by the way, I have all the solar system objects loaded. You can do that in Stellarium. And I looked during the time frame, and I went back and forth, and nothing popped up there for an asteroid. So I thought that was very interesting. So I did some more digging around, and finally I found myself on the MPC, that's the Minor Planet Center MPC checker, Minor Planet Checker. So if I put in the date that I took, and it's in UTC, Universal Time, if I put in the date of my image, and by the way, it's got year, month, day. Notice there's no hour. I have to use partial days in terms of decimal points. In other words, a 100th or a 10th of the day. That's how you put in hours. Then I went to Stellarium, and I just put my cursors on the approximate location in my image that this suspected object's at. If I hit play here, where is it? Right there. So I put the cursors in Stellarium right about there to get me a J2000 right ascension declination set of coordinates. Then I can throw it in the MPC's checker here. And then I can put in a search radius, and I can limit the magnitude. Like, I don't want 100 bright things showing up, so I can't even remember what I put on here. Again, I'm not going to bore you with a demo, but I hit produce list, and it runs, and they've got over 100,000 items in their database of minor planets, asteroids, and everything. And it took me about 4 to 5 attempts, because every time I hit enter, nothing would pop up in this list. And I actually got a little excited. In fact, I'll be honest with you, my next step that I took was on the Minor Planet Center's homepage here somewhere. I was like, all right, I think I've discovered an asteroid. Where do I post this? How do I get it, my name on the list of people who's discovered? Because I know somewhere else out in the world, somebody's imaging M45, right? And I looked, and one of the things they tell you on their page here, and again, it's a different page here on the Minor Planet Center's homepage, not on this one, but they tell you, come here, double check, because we get a lot of false, announcements, whatever you want to call it. So I came in here and realized that I'd gotten, I think it was the date. No, it was the coordinates. I'd gotten the coordinates wrong. So I recalculate the coordinates, I put them in there, I hit produce a list, and sure enough, up pops, what was it? Oh, 793 Arizona. 793 Arizona. And I thought, okay. So then I went back to Stellarium, searched for 793 Arizona, and guess what? Now it pops up. I used the time adjustment tool in Stellarium to show me where 793 Arizona would be, and guess where it was during the time during the time in which my images were shot. Yep, sure enough, M45. So that is how I discovered, quote unquote, that this indeed was an asteroid. And again, if you go to PixInsight in their blink process, zoom in here like I always do. I've actually discovered some pretty interesting stuff by doing this. Sure enough, there's our asteroid. And this has happened several times where I've saw something moving, or I went to astrometry.net, loaded something up, and just went back and forth. I moved that slider back and forth and discovered there was something there that wasn't in their imagery that I had captured, or that a star had moved a significant amount over time, and that's what we call a high proper motion star. So it turns out 793 was the 793rd comet discovered by Percival Lowell, and if you're familiar with him, he built and was the manager, or whatever you want to call it, of Lowell Observatory in Flagstaff, Arizona, which is where Clyde Tombaugh, I believe in 1933, at the age of 30, discovered Pluto. And I say discovered, it was actually discovered mathematically before it was ever found visually, but he was the one that took a number of pictures on glass plates, and he blinked them, compared them, overlaid them, and looked for something that had moved over time. And sure enough, that's how he found Pluto. And Percival Lowell, by the way, was just in love with Arizona, which is why he built his observatory there. But he didn't want the asteroid named after him. He wanted the credit to actually go to the state that he loved, and that's how it got its name, 793 Arizona. All right, what I did real quick, there was a very short break in the video there that you didn't even see, but I hit pause and went ahead and called up Stellarium and called up the date that I had shot those images that you saw, and sure enough, here's 793 Arizona after the fact. In fact, I think that little dot may be it. Yeah. So absolute magnitude 10.0. Apparent magnitude's 14.07. You can't see it in the field of, actually, let me drag it down if I can. Yeah, there we go. 14.07 magnitude. And I can't even remember its size. Oh, yeah, there we go. 34 kilometers diameter. So, very interesting. But that's it right there. And if you hit play, down here, just let time run its course as M45 moves along. In fact, what you could do is, and just rotate through the days. So now it's the 16th of October down here in the corner, and let's go to the 17th. Let's tell it. We want to 17th. Now watch it move relative to the stars. In fact, let's come back to the 15th. 17th, 16th, 15th, 14th. So you can see how it passes through M45 over a period of 4 or 5 days. And I happened to catch it. So again, another video similar to what I've already got on several there on my channel, but I wanted to show you how you can use some of the tools out there, the planetcenter.net, astrometry.net, Stellarium, and then a blinking tool. And you don't even have to have a program that does blinking. You can take these JPEGs, if you're shooting in FITS or RAW, convert them into JPEGs so that you can play around with them and your computer isn't going to get bogged down slamming around 230 megabyte RAW files. You'd rather throw around 5 megabyte JPEGs if they're even that big. But you can run through those in the Windows Photo Viewer quickly and look for little details. Look for something that's moving over time. Blink between the first image of your imaging session that night and the last image and see if you can tell that something has moved. And you got it. I have spent several days on a single image in astrometry.net, going to that worldwide digitized sky survey site that I showed you, looking for any suspicious items that have moved. So that is how I imaged unintentionally 793 Arizona. Hope you enjoyed it. If you got any questions about how to use any of these programs or any of these websites, just post it down below. I always enjoy chatting with folks that leave questions or have comments. I appreciate you watching. And if you like this and the other videos there, click like, and I'd ask you to subscribe. Have a good one. Bye.